Okay, everyone, welcome to Promotable and welcome to Data from Managers, Machine Learning Edition. So we've got Max Rothstein coming on in a second. Really impressive career. I think you guys are really going to enjoy this one. Before we get started, I have just a couple of quick announcements, and then also, thanks everyone for showing up. I know there's lots of places you could be, lots of other webinars you could be watching. So always appreciate that everyone comes out and watches our events, and we work really hard to bring you top speakers that really want to be here and really enjoy connecting with our audience. So aside from that, Promotable, who are we? So I'm Aaron Falus. I'm the founder of Promotable. So we're a workforce accelerator, really trying to close that data skills gap. So how do we do that? We do that through events like tonight. We do these every week. Next week, we've got a data and analytics lead from Here Technologies, so stay tuned for that. And then, of course, we also have classes as well, other classes and workshops. So if you're like, hey, I'm a marketer, a product manager, or a finance person, and I really want to dive deeper into data, learn how to use Tableau, SQL, Python, definitely check out our courses. They're about 5 hours a week. So not a crazy time commitment, all in the evening. So everything is also recorded, so you can go back and catch up on Saturdays or what have you. If anyone's interested in that, feel free to just drop the line over in the comment section. I'm happy to connect with you after the event. And then aside from that, really excited to have Max here. So I'm going to hand it back off to you in a second, and then we'll take it from there. And then, guys, during the event, as Max is talking, if you have questions, please feel free, put it in the comment section or tweet us. I'll collect all of those questions, and then we'll start answering those immediately after the event. And so with that, let's kick it off. I'm going to add you back on here, Max. Add the live stream back on, and you're good to go.
Awesome. Thanks so much, Aaron. Appreciate the intro. Hi, Max Rothstein. I run growth and CX strategy for Avant, which you guys may be familiar with. It's a unicorn fintech company based in Chicago, primarily focused on credit products. Prior to coming to Avant, I've worked at other fintechs, and my background is primarily actually in consulting. So you might be wondering, why am I here to talk to you about machine learning? And how that can apply to careers in management across sort of industries today, given that background. And that is very much what I'd like to kind of answer through this talk, which is why should everybody learn about ML tools? And why are these helpful for anybody? And I think that there's sort of an important transition that's happening in terms of data's centralness to overall business strategy. I think that previously, there had been this understanding that a lot of people, big data is a thing that a company needs to do, right? We have to be making decisions based on our understanding of the data and our analytics, and those things are really starting to actually come to the fore in a way that's more meaningful. I think previously a lot of people had kind of collected these large data sets and not really known what to do with them or how they could actually inform their strategy decisions. And many companies have started to kind of turn a corner around that and find ways to make more meaningful use of the data that they have. And this is in some ways similar to what we saw with the internet revolution in the early 90s. Whereas previously, every company was looking for like a webmaster to manage their front and back end of their site. He was like the go-to person in your company for all things internet related. As things became more ubiquitous and more commonly used day to day, you started to see roles become increasingly more specialized. So now we don't really have webmasters. We have like a Scala engineer who's in charge of your back end system. We have like a React engineer who's in charge of your front end. And you start to see that the sort of expectation around what the average level of competence is with regard to these subjects increases as they become more central to the day-to-day decision-making that your business is doing. So I think we're seeing something very similar with data science right now. Whereas, a few years ago, everybody was looking for a data scientist. There's still a lot of general postings for data scientists. You're starting to see things that are like a lot more specific. Like we want somebody who is an Azure ML specialist with 5 years of experience, working in this field. And we want them to be focused on like natural language processing algorithms. So you're starting to see that at the highest end of this stuff, it's becoming increasingly specialized as people begin to sort of focus on specific areas of data science. But the expectation is going to be that as this happens, there's like there's a general understanding that will be expected among sort of all management who work in industries that are making data-driven decisions to understand sort of what are these models doing for us, how are they useful, and how can they be used. And so in order to enable that, a lot of the people who work on the open source packages that allow you to use a lot of these models have made them more accessible, but they've also sort of changed who the audience that they're targeting the packages at are. So whereas previously, the expectation was anybody who's going to be implementing one of these models is probably has a deep background in statistics, is a data engineer, is probably working as a data scientist. There's an increased awareness, especially in the sort of larger projects that are being worked on, that a lot of the people who are going to be implementing these models are analysts or managers. And the way that they sort of interact with the tools has become much more accessible as a result of that. And then the sort of final reason that you should be interested in learning about this stuff, even if you're not somebody who's specifically a data scientist, is that these are really effective ways to help save you time. And if you can use these tools in a way that kind of helps you avoid doing hours and hours of more manual analysis using like a pivot table, you'll be really happy that you took the few hours it required to learn about how to use them and implement them effectively. So I'm going to go through a few examples of like how you can do that and apply them to sort of different types of problems. But I think the most important thing to understand is that the key question you need to really ask yourself is, what models are useful for what problems? And then how can you figure out how to take the data that you have and develop some insights from it based on the output of those models. So George Box was a brilliant statistician who did a lot of seminal work around time series analysis particularly, but contributed to a number of areas of statistics. And he's well known for his statistical work and modeling, but also for this aphorism, which is that all models are wrong, but some are useful. And I think that really gets at the crux of what I'm driving at, which is essentially that you'll never have a model that's so perfectly tuned, so highly parameterized that it's going to accurately represent reality. That's not something that's going to be possible in the immediate future, though GPT-3 is making long strides in terms of human speech. What matters most is whether or not the model that you're using is useful for solving the problem that you're trying to understand. So he's not as well known for a quote that he put forward later in that paper where he said all models are wrong, but some are useful. Basically, he said the scientist's job is to understand where their focus needs to be. And so it's not to be focused on mice when there are tigers afoot, meaning you need to figure out what problem you're trying to solve, what's the tiger in this situation, and then find a model that can deal with that. And don't get too caught up on having a perfect model. Don't get bothered with the mousy details, the sort of small imperfections in the model. Just figure out, is it a useful way to look at the problem, and will it give you useful insights? So the next sort of thing that you'll need to figure out once you start diving into this world is like, what kinds of models are useful for solving different kinds of problems? And as I said, I think that's really the most important question. I think once you know what kind of model you'd like to use, you can figure out whether you have the data that you'd need to put into it, and whether or not you need to kind of do any transformations or do any what they call data munging in order to make features that'll be usable for the model to ingest. But again, key question is, what tool am I using to solve this problem? So 4 examples that I pulled out are classification and regression trees, or CART analysis. That's extremely useful for segmentation and building human readable rule sets. The Facebook profit model, which is really useful for forecasting a time series, and it's very easy to use. I'll cover both of those in the 2 examples that I'm about to go through. And then random forests, which are sort of a beefed up version of CART analysis, where you take millions and millions and millions of different sets of regression or classification trees, test them on different data sets, and develop a really stable model. And then GPT-3, which you guys have probably seen in the news, is an incredibly powerful natural language processing algorithm that can generate human-like speech. So depending on what kind of problem you're trying to solve, you can select what model type might be most useful, and then what subset of that model is going to be the most applicable. So I'm about to get into an example where I'll sort of talk through why you might want to use card analysis instead of sort of the more powerful random forest. So the first example that I wanted to talk through is customer segmentation. And in my work running our growth strategy at Avant, this is something that I do constantly. We have, a very diverse customer base that spans the country. And we also have credit characteristic data for the vast majority of people who, apply for a credit product. So in addition to that, we've got all of our, web and mobile data, as well as any data that we get passed from the marketing channel that we're using, be it either a digital channel or a performance marketing channel or a partnership. So understanding how we can take that huge data set and develop some useful insights around how we can segment those customers is an incredibly important task. And one that's very applicable across a variety of fields. You'll be asked to do some kind of customer segmentation in basically any go-to-market strategy. So in our case, what we were trying to do is figure out, all right, we have all of these customers coming in at the top of the funnel, and we'd like to figure out how much we can pay to acquire them. Again, very common problem if you're trying to solve for overall marketing strategy, be it in a startup situation or at a more mature company. Understanding what you can pay in order to acquire a new customer is kind of one of those fundamental business problems that everyone needs to solve. So as I said, we have these huge data sets, and it almost doesn't matter what your classifiers are in this case and what data you have on the customer. As long as you have a significant amount of data, you should be able to figure out a meaningful way to draw a segmentation using one of these models. So in this case, the most powerful, as I said, model that you could apply would be to build a random forest. And XGBoost is like an extremely effective random forest. And if you have a whole data science team and it's a really important problem for you to solve as a business, then that's a great way to do it. The output you'll get from that will be like a score that'll kind of predict the likelihood of something to happen. So if you wanted to segment your customers based on how likely they are to convert, you could have your data science team build an XGBoost model that'll give you a numerical output and tell you how likely that customer is to convert based on the attributes that they're seeing about that customer using past customer performance to predict it. And that's great if you have that whole infrastructure and you can deploy this model for scoring, because it allows you to really powerfully segment the customers. But there's a much sort of simpler method, which is actually the basis for the random forest models, which is a classification tree. And classification trees, rather than giving you like a score output, will give you a human readable rule set that will allow you to put in place the segmentation through other means. So in this case, we were working with a performance marketing partner who had a lot of consumer data before the sort of customer leads are sent to us. So we could instruct them which leads we'd like to be sent based on how likely they are to convert and how much we're willing to pay for those leads based on how likely they are to convert and how we think they'll perform once they get issued a credit product. So the advantage here is that in a scenario where you can't like deploy an XGBoost model, you can come up with a really simple rule set that's easy to communicate to a partner who you're working with. Rather than try and build and deploy and maintain a modeling infrastructure, which is a very complicated and expensive problem to solve. This is like something you can do in a couple hours that'll give you a really powerful segmentation and help you drive better results. So I think the one thing you need to ensure you do have in order to make this approach work is like a sufficiently large data set. So you'll want to have thousands and thousands of records, ideally like upwards of 10 to 15,000 records, but you could do it on a much smaller set as long as you're comfortable with a simple rule set with maybe 4 or 5 significant rules. You could do this on a set that only has 500 or so leads. So I think it's also applicable to scenarios where you're working with like a digital channel where you could build potentially a lookalike audience. You could develop a rule set for what a high converting population looks like, then use that to pull together what your seed group looks like for that lookalike audience, and then push that into your response channel in order to allow like Facebook or Google Display Network to kind of optimize around customers who have similar attributes. So the question you want to ask yourself at the outset here is like, which model is going to be least wrong, right? Because that's when you first start modeling, that's like what everybody's obsessed with is how predictive can it be? And and how great is that? And as I said, XGBoost, incredibly powerful, very predictive, will be very accurate. But rather than asking yourself sort of which model is least wrong, what you should be asking yourself is which model is going to be most useful and which model is going to be most useful relative to the time and resources that I have to solve this problem. And so in this case, this wasn't something where it was worth building an entire ensemble model or boosted tree model. It was something that we wanted to solve in a couple hours. We had a couple analysts and a little bit of my time to look at it. And so in this case, just building a simple classification tree was like a much simpler and more effective way to solve the problem given the resources and time that we had. So this is an example of what sort of your decision tree output will ultimately look like. And what we did was we took all of the credit characteristics that we had about these customers when we first saw them coming into our leads funnel, and we allowed the model to determine how to split that data. So what the classification tree model is actually doing is it's looking at all of what we call classifiers, which are like the characteristics and attributes of the lead that you fed into it. And it's using those to determine how likely somebody is to have a target outcome. So in this case, the predicted variable that we gave it was whether or not somebody was going to actually convert and accept a loan product. So what the model does is it looks at all of the different classifiers that you've given it, and it tries to determine how it can draw simple splits in the data in order to generate information gain. And I'm not going to get too far into how it determines information gain. I could refer you guys to some resources that you can look through. There are several different methods of calculating information gain. But basically what you need to understand is that what the classification tree is going to do is look at all of the different variables that you've given it to try and predict the outcome. And it's going to determine what the most effective one is at predicting that outcome. And that's going to be your sort of top level node that you see here, which is that collections variable. Then once it splits the data set in two, it's going to look at these two outcome data sets independently. So everybody who has this collections variable under 1,000 will be in set A. Anybody who has it over 1,000 will be in set B. And it's going to go, okay, the most effective split at the first level was collections variable less than 1,000. What's the most effective split at the second level? And what it's trying to do is ideally create populations in what we call the terminal nodes here that are as pure as possible. And by pure, I mean a perfectly pure set would be you have one node, so like this node where everybody converts, and then in all of the other nodes, nobody converts. So it's trying to figure out what the most effective way to cut the data is. And it's going to be a lot quicker than anybody trying to do this using pivot tables and running a million different splits would be themselves. So this is a case where using this model is sort of your first cut at it when you're trying to understand what's going to be indicative of a lead that's likely to convert. It's just going to be a much, much more effective way of approaching this problem than trying to put it all into Excel and then cut it a million different ways yourself. So what we found out from running this analysis was that there are several variables that are extremely predictive of whether or not somebody's likely to actually be issued a loan. The first one, as I said, is this collections variable. So, if somebody has had a large amount in collections recently, meaning they, hadn't paid one of their bills for several months and it had actually been sent to a collections firm, they're very unlikely to actually get issued a loan product. Then once you sort of go a little bit further down the tree, you see, okay, somebody who's had a mortgage for a long time is pretty likely to get issued this product. And what you'll see is these conversion rates here, which are scaled based on sort of the baseline population. The combination of just these two very simple rules yields a population that's twice as likely to convert as the overall average of sort of all the leads that we're seeing. So that's really useful, right? Because if you're in a performance marketing standpoint, you can say, okay, this is great. We will pay you twice as much for customers who meet these two criteria than we will for the average lead because we know they're that much likely to actually get issued a product. And then sort of on the other end of the scale, you've got people who have had collections and who have trade line delinquencies, meaning they have trade lines that are past due, that are about 1/5 is likely to ultimately get issued. So in this case, based on our overall cost of acquisition, what made the most sense was to just talk to our performance marketing partner and ask them not to send us any leads that met those criteria. And by doing that, we were able to boost the overall approval rate of the remaining population about 20%, which is not insignificant amount. Uh, so this was a very simple exercise. It took a few hours and it yielded great results. We were able to get significantly more of the leads that are sort of in this green box that are twice as likely to convert by just agreeing to pay up 50% more. So if you can pay 50% more for something that's going to be twice as likely to convert, you're going to do that all day, every day. And we were able to eliminate this low converting population that was bringing up our costs without really doing much for us on the bottom line. So that's sort of a simple way you can apply this in a performance marketing setting. If you were trying to apply this to like a response channel, like digital advertising through Facebook or something, what I would suggest doing, as I said, was just use this rule set to build a lookalike audience and then set the spend caps for those audiences at like, 1.5 to 2x what you would for the normal audience. And you should get some really good results out of that. And, this is a lot less painful than taking hundreds and hundreds of variables and putting them into a spreadsheet and then spending several days and a lot of analyst time crunching those numbers. Is it going to be absolutely perfect? No. Is it the most stable possible version of this model? Also, no. But for the problem that we were trying to solve, is it useful? Absolutely. Is it effective? Absolutely. And so I think that oftentimes, we get bogged down in these questions of like, how do I build the perfect model? And I just want to bring us back to the most important thing is not whether the model is completely accurate. It's just whether or not it's useful for solving the problem you're trying to solve. So second problem I want to talk about is forecasting. Forecasting is an issue that you run into in lots of areas of business. One of the most common ones is forecasting revenue. In our case, we were trying to forecast loan originations, which is very closely tied to revenue. And this is something that is, rarely something you want to spend enough money and energy on that you've got a whole data science team focused on it, unless you're at like a huge publicly traded company, in which case you're being held to those forecasts and missing on earnings per share can have huge implications. If you're at like a mid-sized company or even a large private company where the forecasts are just being developed for internal purposes and strategy and planning, it's important to be able to produce an accurate forecast without putting a ton of work into it. And so in order to kind of solve that problem, the core data science team at Facebook developed a model over the past few years that they call Profit, which is a very cute sort of pun. Many people use it to forecast profitability, and the model can be very prophetic. So I think aptly named. And the purpose of the profit model is really to take sort of these complicated autoregressive integrated moving average models, which have typically been used to solve these kinds of problems. And something that, as I said, George Bach spent a lot of his life developing. Those are incredibly effective models for solving these problems at scale, and create an alternative that can be easily implemented by like a single analyst with just access to the data sets they have and limited data science training, but a solid understanding of what really is driving the business. And what other things might come into play that would affect the overall forecast that the model might not know about because they're, not shown in your historical data. Like, let's say, you're launching a new product next quarter. Somebody on your data science team might not know that, but an analyst working on the team that's going to do it absolutely will. They can take the output of this model and then really easily adjust it based on what they know is going to happen in terms of business changes that are planned for next quarter, next year, next month, whatever sort of interval you're trying to forecast over. And whereas the ARIMA model requires a lot of parameter optimization and fine tuning of what parameters are being fed into it, the profit model takes an incredibly simple series of inputs. The only required inputs are a time series of your historical values and then the actual variable itself you're trying to predict. So in this case, we were able to predict loan originations using just the daily originations data that we had from the previous 2 years. You can add in additional variables and parameters around what kinds of seasonality you typically see in your business. So by looking at the trends over the previous couple of years, we noticed that, there's definitely a yearly trend that's pretty consistent, both for our business and for the industry. And there's also an intra-week trend where originations on Tuesday are higher than Monday and then kind of trail off for the rest of the week. Some businesses have intraday or intra-month seasonality. The model can, accommodate those things. You can also add in a list of holidays, since those obviously may impact business, or even add additional regressors. Like once you get comfortable with the initial model, you can get a little fancier with it and try and add other things that you think are predictive of whatever time series it is you're trying to forecast. But again, the only two things you actually need are the time series component and the variable that you're trying to forecast. So what we were able to do from this was develop a really accurate prediction of what we were going to issue on a monthly basis. And what the model does is it uses a method called Fourier decomposition. And what Fourier decomposition does is it was actually developed for for physics, for looking at sort of physical problems. So looking at like a standing wave that you might see, like if you're trying to work with optics or something of that nature, and decompose it into its constituent parts. So similarly to sort of the ARIMA model that Box developed, what you get here is you get a series of different moving, that's a terrible way to phrase it, but a series of different moving series. And what it's done is it's separated out the constituent components that are seasonal based on their sort of time frame. So what the model has told us is basically, this is what your weekly trend looks like. Issuance is low on Sundays, Monday bounces back up, Tuesday is going to be your peak, and then it's going to kind of trail out for the rest of the week. So, all right, great. It understands how things move on a weekly basis. It can give you those parameters. Then it'll look at, all right, what's your intra-year trend? How does the market sort of move on a month-to-month basis and even on a week-to-week basis? And one thing that was very cool was when we got some originations data for the personal loan industry as a whole, it mapped really closely to what we were seeing as a company. So it was really validating to see that what was typical for our seasonal trends was also typical for the industry, and that the model was able to pull that out so easily. Then what you've got here is the holidays. So this just shows, there are many holidays throughout the year where issuance will be lower than expected because people would rather spend their, 4th of July doing something other than applying for a loan. And then this is the overall growth trajectory for our business. So by combining these sort of 4 disintegrated series that it's created, and then layering on these red lines, which are change points in this overall trajectory for business growth that it's identified, it's able to produce a pretty robust forecast for how many loans we're going to originate on any given day. So we were able to actually backtest the forecast that we got relative to the historical actuals. One good practice when you're sort of building these models is you may want to hold a month out when you're doing something in order to determine how effective it was. One great thing about Profit is that it does what's called the cross-validation for you. So there's no need to hold months or what's called an out-of-time sample out of your model development. You can just give it all of the information that you have and let it fit the curves for you. So what we were able to do was look at sort of its ability to predict our originations on a monthly basis, and the mean absolute percentage error, which I think is a good way of looking at sort of the deviation of forecast versus actuals when we back tested it against the historical data, was only 2%. And if you're only off by 2% on a month-to-month basis, if you're not a huge publicly traded company where missing earnings per share by a few cents is going to matter a lot, that is a very accurate forecast. So again, take a while, think about what kind of resources do you have to solve the analytics problem you're trying to solve. Is this something you can spend a lot of people's time on? Is it something you can get a specialist looking at and really bring in a data science team? Or is it something that you need to solve relatively quickly and without spending a huge amount of effort on it? And if that's the case, I think you should seriously consider using one of these methods rather than working with a data science team to build a more robust model, because a lot of the time you're going to get 95% of the value that you would have gotten out of the more sophisticated model that you would have your data science team to build, and you haven't taken up their time from other sort of higher priority problems that they need to solve. And in addition to that, you haven't taken up a ton of your analysts' time trying to figure out just eyeballing these issues and running them in a pivot table, like what's the most effective way to split this out? What do we think is going to happen with growth rates? Those sort of ways of approaching these problems can take up a lot of time and not necessarily give you a great result. These are wonderful tools because they're easy to use and they deliver powerful results. And again, I'm not a data scientist. This is something I have learned about through my career and just through my work, and have gotten great results from doing. But I think it's something that everybody who works either at the analyst, management, director level should invest some time in doing, because these are great tools they're only going to continue to get better throughout our careers. And it's definitely worth investing a little bit of your time, either after work or on the weekends, just to understand how to use them. Because I promise you, the time that you spend learning about how to use these tools will pay itself back almost immediately. I can't stress enough how important it is to understand the problem you're trying to answer, and then figuring out which tools are going to be most useful to answer that problem. It's so much more effective than running around and trying to cut something a million different ways yourself and not necessarily knowing whether you can be confident in the result. So in summary, data should drive your strategy. That's only going to become more and more important as data sources become more widely accessible and people become expected to understand how to use them themselves rather than farming this out to a data science team. The general proficiency that's going to be expected with ML models and ML tools is going to be increasingly important for management, not only if you're implementing these models yourself or if your team's implementing them, but if you're working across teams, say with an analytics team, you want to understand how to interpret the results. And if you're the subject matter expert, it's going to be really important for you to be able to give meaningful feedback on how the model was developed and whether or not you think the results that it's predicting are useful, right? Because if the model's not useful, you should scrap it, go back and redevelop it. And if you don't understand anything about sort of how the model framework works, it's very hard to give that feedback effectively beyond saying, no, we don't like this. We don't think it lines up with what we think is actually going to happen with revenue growth, which is not particularly helpful feedback. If you can say, hey, I think that this model is probably off because we need to add an extra factor that accounts for seasonality, that's incredibly targeted feedback that your analytics or data science team could take back and incorporate with their model development. Finally, as I said, the ML tools are much more widely accessible and easy to implement than they used to be. So you can take and should take these problems on yourself and learn how to solve for them so that you don't need to take up other teams' time implementing these things. Because again, if you're the subject matter expert as sort of the manager of this area of your business, you're probably going to actually do a better job developing this model than the data science team, who might not know what data would be useful in terms of trying to predict a problem or forecast a time series, right? You're the one who really understands what's going to drive this for your business. And so you're actually the most qualified person to assess what data should be used in order to develop that forecast or in order to build that predictive model. And then finally, it'll save you a lot of time. Simple and effective models save time. And I am somebody who doesn't like to burn a lot of time trying to solve a problem when I don't have to. So again, I would encourage all of you to sort of take the time to learn about these tools. There are a ton of free resources that you can use. There are also many great courses that you can sign up for, including courses through Promotable that'll help you get more comfortable using and implementing these tools. But I think this is the direction that business is moving, and you definitely want to get ahead of it instead of find yourself falling behind. So thank you guys for giving me the time to speak with you. And if you have any questions now, or I think Aaron had some questions for me that we can talk through before we get into a wider Q&A.
Awesome. Well, that was really, really good. I think if people were actually here in person, we'd be able to actually do the clap and all that sort of thing. But there's a couple questions already from the audience, although I'm going to take the moderator's prerogative because that's so I'm here. But I think some of the really important questions that you kind of touched on at the end that I think deserve like an extra couple of minutes are, if you want to kind of go from being that subject matter expert, regardless what functional area you're in, and you want to learn to communicate more with those data scientists or your technical team, like how do you kind of start that process or learn how to be that person in the middle?
That's a great question. So I'd say that one of the first things you can do is sort of start reading about the kinds of models and tools that are helpful for data scientists, and then start to understand kind of what I was drawing out in this talk of like, what types of problems does my team have, and what analytical tools or modeling frameworks would be useful for solving those? So if you're somebody who needs to understand how to forecast things, it would be great to just dig into time series analysis and look at as many resources as you can find on that. Because what you'll find is that there are a number of different frameworks that you can use to solve these problems. And the more you understand about what the data science or analytics team's approach to solving it is going to be, the better the feedback you'll be able to give. So I would say figure out what sort of business problems you need to solve. Are you trying to predict something in order to determine how to spend marketing dollars effectively? If you are, then you're probably worried about customer segmentation. Are you thinking about customer experience and how you can sort of streamline different, more personalized customer experiences for different customer types? Then you might want to look into either, I guess, what we call clustering analysis or the sort of classification trees that I was laying out earlier. And there are honestly, a lot of blogs that might be very helpful. So for somebody who's not, comfortable signing up for a class immediately, that might like get you to that point where you're comfortable taking the next step towards data science is a great one that I've read a lot of. So I definitely encourage people to go sort of read around there. But yeah, I'd say think about something that's really central to what you're doing, because that's what's always going to stick in your brain, right? Like if you're trying to just solve these problems in a completely abstract way, it's going to be painful to force yourself to learn about it. You're not going to enjoy it. But when you have like a really concrete problem that you need to solve for your business, or just something you're interested in. I mean, hell, if you want to go use this to kind of predict the stock market and do some day trading on Robinhood, like you could absolutely have that as your use case as well. Just figure out something that you're passionate about, either for personal reasons or because of what your role is within your business. And then try and start Googling, what you think would be a useful modeling framework. So if you need to forecast something, I would literally just Google like time series forecasting, machine learning, and start from there, because there will be a lot of great think pieces you can dig into. And hopefully that'll get you comfortable enough with what's out there to really start diving into some courses.
Awesome. So it sounds like really figuring out what your problem is and what you're trying to do. You start there and then dive into figuring out what kind of tools or coding languages or what have you need. I'm going to start with some of these questions here. So we'll give you a second to catch your breath as well.
For sure. Thank you.
From Adam Kalish, I apologize if I just butchered your name. He asks, how will 5G and mesh and edge networks impact machine learning?
That's a very good question that completely candidly, I don't have a great answer for. Not an expert in data science, not particularly familiar with those frameworks either, frankly. Maybe we can follow up in the discussion afterwards and you can help me understand how those work and we can talk about how we think that'll impact ML generally. But again, not an expert in machine learning by any means, just somebody who's learned how to use these tools effectively to solve business problems.
Awesome. So next question coming from Ravi. He was asking about on your PowerPoint, how to interpret the second graph on the profit model output, backtesting and percentage error slide. He missed that.
For sure. So let me just share my screen again so I can go back to that.
Gotcha.
So that's a great question. So basically, the way that you should understand this is when you're looking at the top graph, those are the actuals for 2017 and 2018 in the blue. And then the forecast that the profit model would have developed using all of the data prior to that date is what's in red. So that would be the most recent forecast. So the 30 days that it had forecasted it out using the prior several years of issuance data in order to develop that forecast. And then the bottom chart is showing you what the delta is between that blue line and that red line. And it's doing it on an absolute percentage error basis. In some cases, you'll care more about whether or not you're over or under forecasting, and it's better to err in one direction or the other. In this case, we wanted to do the absolute percentage error because I was more concerned about just the magnitude of how far off it was, not the directionality of whether it was off high or off low. And so that shows basically, like here you can see there's like a visible gap there. So that month we would have been off like 7%. Here the lines are basically on top of each other, and you can see that in all of those months the error was under 2%. In March, again, we were off by about like 6-7%, and then it sort of came back down. So the mean absolute percentage error was only 2%. So when you look at sort of what the average percentage error was across that whole forecasting period, it was typically off by about 2%, which, as I said, is good enough for the work that we were doing. If you have to get way more accurate than a 2 to 5% error, I'd suggest using an ARIMA model and really working with your data science team in order to get that built out. But great question, and thank you for asking.
Awesome. So last question here from Jennifer. So she was just asking, I think she's touching on just general that the sometimes tentativeness or hesitation of folks to give up increasing amounts of their personal data, I think. But she's asking if how much business do you think you or just folks in general, companies in general, might be losing because people don't want to give up, or people want to give up as little data as possible to advertisers and financial companies, using transactional data. Anyway.
Yeah, so that's a great question. And I think it's becoming increasingly relevant, right? Like as we sort of see the moves that iOS is making with iOS 14 coming out to preclude advertisers like Facebook from being able to do cross-device stitching using their IDAF, it's going to be increasingly more difficult for people, from a business standpoint, to get access to this data that you can use to action audiences kind of across devices, across websites, across networks. So the question of consent and data harvesting is only going to become more and more central to how we operate. In financial services, we're lucky enough that, credit bureaus exist and we're able to get people's credit data. So at a minimum, we have that. But yeah, I mean, as GDPR-like legislation, CCPA-style legislation becomes more common, and I would expect that to be a very rapid trend. I expect a lot of adoption over the next 2 years of legislation in the United States that's very similar to the CCPA Act. It's going to be more and more difficult to get that data. So what I would say is you'll always be able to have users opt in to your site data. And so at a minimum, when you're trying to design great customer experiences, you'll be able to see how customers interact with the website once they're there. And if they've authenticated, hopefully they'll be willing to let you collect that data. But yeah, you're absolutely right. It's going to be increasingly difficult to kind of get these third-party marketing data sets that you might be able to train these models on. So it's going to be a headwind that we're all facing and something that we need to figure out how to solve for. But as a consumer, honestly, I love it. I think that we should all, have a greater degree of control over how our data is shared, used, and sold. So on the consumer side, I'm a big fan. On the business side, obviously from a marketing standpoint, I'd love to have all of it. But I think there's a correct balance there, and we'll figure out what it is.
Yeah, absolutely. Well, that's all the questions we have time for here. For those of you who signed up for our post-event interactive Q&A session, you should have received an email with the Zoom link for that session. So we'll be transitioning over there in a few minutes here. But aside from that, Max, thanks a lot. Really amazing talk. I think, one of the most important things that I think everyone should learn about is just, finding that problem, finding that issue you're looking to solve, and touching into it. We've got one more question Sam, I just saw this come up, so we'll ask, if you want to just do a quick 30, 60 second answer for Sam. He asked, correlate with protected classes. So this is a specific, he's asking about specifically in lending and essentially, and I'm sure I may or may not be getting this right, but talking about, how do we prevent models from essentially doing redlining or other kinds of...
Oh, that is a great question. So that's obviously a huge problem for the finance industry as a whole. And the truncated, not super verbose answer I'll give you is that a model like XGBoost, which I was describing earlier, where it's very difficult to interpret what factors are driving the results, creates a lot of problems for regulators in terms of understanding how you're making the credit decisions you're making. So from a marketing standpoint, using something like a classification or regression tree where you have a human readable set of rules and you can show them to your compliance team and say, look, we're not using any variables that are directly related to protected classes. None of these will create a disparate impact for any of the audiences we're marketing to, is a really great way to be able to use these models without having to solve for sort of the intelligibility of the model output and then explaining that to your internal compliance team or your regulators. So great question. I think that feeds really well into the why you might want to use a CART model instead of an XGBoost setup. But the interpretability of machine learning models is only going to become more and more central to how regulation is crafted.
Awesome. Well, with that, it's a wrap, guys. Thanks, Max. That was actually a really, really good, concise answer to that question. I think it's a challenge that you're starting to see with like the Microsoft Racist bot, and it just keeps going. So
yeah,
definitely
absolutely.
Love the answer. Everyone, thanks again for coming. Definitely check out next week's event as well. We'll be having these regularly. Feel free to, of course, like us on LinkedIn. You're already here anyway. And then definitely going forward, we'll have this process. You saw the emails from us. Tweet us your questions beforehand so we can get those out immediately. We can even potentially get that into the presentation. We'd love to see all of those questions come out. With that, again, I'm Aaron. Feel free to send us an email, hello@promotable.io. And then again, for those of you who signed up for the interactive Q&A session, we've got that coming up next. And feel free, again, send that email to me if you have any issues logging on. Thanks so much, guys.